Alright, so we're going to be practicing using our problem-solving steps here to solve some basic velocity and displacement equation problems. Number one here says it takes me 4 hours to drive 320 kilometers to New York. What is my average velocity in kilometers per hour? So, first thing I want to do is write down all the givens. Right, in the given information it says it takes me 4 hours. 4 hours is how long it takes. How long it takes is the time. The symbol we use for time is delta t. So delta t there is 4 hours. The other number I see in there is the 320 kilometers. That's how far it is to New York. That's going to be the displacement there. So that's our delta x. Delta x is our displacement, or how far. We can tell, of course, because the unit is kilometers. So delta x is 320 kilometers. It doesn't look like we need to do any unit conversion here because our delta x is in kilometers, our time is in hours, and we can see it asks for our average velocity in kilometers per hour. So those are the two units that we have, kilometers and hours, so no conversion necessary. We can go on to step 2 here, which is to write the symbol for the unknown. The question is, what's my average velocity in kilometers per hour? So for step 2, I'm going to write my unknown. My velocity is unknown. So it is Vx equals question mark to remind myself that that's what I'm looking for in the end. If I can get an answer for Vx, then I've got my solution. So, next step is to pick the right equation. Of course, the only equation we have is this Vx equals delta x over delta t. Once we know more equations, we can use the symbols that we've written down to help us pick the right equation, but for now we'll just use the only equation we have. But you can see it's the same, it has the same symbols as the ones we've already written down, so we know we can plug in and solve for our velocity. We don't need to do step 4 to rearrange the equation because Vx is our unknown and that's already by itself on one side of the equation. So we can go right to step 5, plug in numbers and calculate. My delta x is 320 kilometers. My delta t, I know, is 4 hours. Of course, I just need to do 320 divided by 4, which is, I think, 8. And the units I have are kilometers over hours. So, my velocity is 8 kilometers per hour. I'm sorry, 80, not 8. 320 divided by 4 is 80 kilometers per hour. Alright, here's the solution to number 2 in our basic velocity and displacement problem practice. This one says an ostrich can run 1.25 kilometers in only 1.2 minutes. What's its average velocity in kilometers per hour? So again, we always start out by writing down the givens, right? And the givens here are that the ostrich can run 1.5 kilometers. That's how far he can run. How far is a distance or a displacement. The symbol for distance or displacement is delta x. So I write delta x equals 1.5 kilometers. It takes him 2 minutes, right? 2 minutes is how long it takes him. How long can be an amount of time. How much time it takes. Delta t is the symbol for time. And our delta t is 1.2 minutes. Now before I go on though, I notice it says make sure the units match and to convert units if necessary. Right? Making sure that the units match. Well, the average velocity, the question in the problem says what's its average velocity in kilometers per hour. And I have kilometers and minutes in my givens, right? My delta t is 1.2 minutes. So that doesn't match up with the kilometers per hour above. So I've got to convert those units. But I can do that. 1.2 minutes I can convert into hours pretty easily. Because I know that there's 60 minutes in an hour. So if I call 1 hour and 60 minutes my conversion factor, minutes cancel out here. And all I have to do is divide 1.2 over 60 to find my time in minutes. 0.02. So Right, so the ostrich takes 0.02 hours to run the 1.5 kilometers. So now we go on to step 2 here, and we write the symbol for the unknown. It's asking for the average velocity. That's my Vx. So that's what I'm looking for here. So I'm going to need to go, when I go to step 3, which is where we're at, I need to pick the right equation for the problem. And in general, we'll do that by looking for an equation that has all the symbols we've written down so far, but this is really early on. We only have the one equation to pick from, so I'm going to write down Vx equals delta x over delta t. I don't need to rearrange this equation since the Vx that I'm looking for is the Vx that I have all by itself on one side, so I can go right ahead and plug in. I know that my delta x is 1.5 kilometers. I wrote that down in my givens. I know also that my delta t is 1.2 minutes. I wrote that down in my givens, so now I just have to, I've converted that to 0.02 hours for a reason, right? I wanted my units to work out to be kilometers per hour, so I'm going to, when I plug in for my delta t, I want to use the version of it that's in hours. So, now I just have to do that division. I have 1.5 in the numerator divided by 0.02, which is in my denominator, gives me 75. So, 75, and the units I have there, kilometers per hour, is going to be my velocity. My velocity, the ostrich's velocity. Alright, so here we go. We've got number 3 in our velocity and displacement problems. We're going to start out, as always, with step 1, writing down all the given information. We know the Sears Tower is 443 meters tall. That means that's our vertical displacement. Delta y is the symbol we use for our vertical or up-down displacement. If you were to use delta x here instead of delta y, that would be okay for now. But we are going to need to use both in the same problem at some point here, so we want to get used to understanding the difference. If you climb the stairs with an upward speed of 0.6 meters per second, how long will it take you to get from the street level to the roof? That 0.6 meters per second, that's our velocity, and we can tell because the unit is in meters per second, right? And if it's meters per second, we know that's got to be a velocity. And of course, I'm going to label that Vy instead of Vx because it's a vertical motion. And we don't need to convert any units in here because our velocity is in meters per second and our displacement or delta y is in meters, so we can move right on to step 2 and write down the symbol for unknown. The question there is how long it's going to take to get up there, and how long is a delta t, or an amount of time, right? Symbol for time is delta t, so delta t is our unknown here. So now we go on to step 3, which is to choose the proper equation based on the quantities you've written. Of course, we know the only equation we have at this point is Vx equals delta x over delta t. But again, I'm going to use y instead of x because we're talking about vertical motion. This time we do need to do step 4 and rearrange the equation to get the unknown all by itself because we're looking for delta t and it's in the denominator over there. So what I can do is the first step, if I multiply both sides by the time, because of course what I do to one side I have to do to the other to keep these things equal. My delta t's cancel out on the right, and I have time times velocity equals displacement. The next thing I want to do to get the time by itself is to get those velocities to cancel out. So I'll divide both sides by Vy. So this velocity cancels out with that velocity. And what I'm left with is delta t is my displacement over my velocity. So that's step 4. Now I can go on to step 5 and plug in my numbers. Right? I know that my delta time, or my delta y I wrote in the givens was 443 meters tall. The y velocity 0.6 meters per second, and we know that's positive, right, because we're moving upwards. So 443 divided by 0.6 is what I want to put into my calculator. And I get 738 about. And for my unit, I have a meter divided by a meter per second. So the meters cancel out, and what I'm left with is seconds. So the time it takes to climb that Sears Tower is 738 seconds, which is a little bit more than 12 minutes. So we should do number 6 and check our answer. The units worked out. I ended up with seconds, and I was looking for a time, so I did that okay. And the number makes sense as well. 12 minutes to climb the stairs of a skyscraper. That seems like a reasonable amount of time.